Hey guys, this is Mr. Gordon here with a quiz review on quadratic functions and equations for Unit 4 Quiz 1, which I'll have tomorrow, Wednesday. So the first thing you need to be able to do is to solve quadratic equations by factoring, by graphing, by completing the square, and by the quadratic formula. Second thing you need to be able to do is convert between different forms of a quadratic function. So we have standard form, vertex form, and factored form. So let's start first of all with solving by factoring, which to me is the easiest method, and as you guys practice, I think you'll feel the same eventually if you don't already now. So this is a trinomial. I want to factor it using the x factor. So x and x multiplies to give me x squared. Negative 6 and 4 multiply to give me negative 24. And if I check the diagonals to see if that gives me the right middle term, I multiply the diagonals and add the result. So along this diagonal, I get negative 6x. On this diagonal, I get 4x. Negative 6x plus 4x is negative 2x, which is the correct middle term. So that means my factors are x minus 6 coming from across the top and x plus 4 coming from across the bottom. So that's still equal to 0. I just factored the left side of the equation. Now I set each factor equal to 0. Add 6 to both sides of this equation, and I get x equals 6 as one solution, or on this side, subtract 4 from both sides of the equation, I get x equals negative 4 as my solution to that equation. So those are the two solutions, the two values of x, that if you plug them in, substitute them to this expression, you will get 0. So that's solved by factoring. You guys' favorite, solved by graphing. Graphing is good anytime that factoring doesn't work, and it's certainly not going to work here. And when you have messy numbers in general, let's just hope and pray that we can do it by graphing so we don't have to use the quadratic formula. So we got x squared plus 1.4x minus 15.51. So I go to my calculator, graphs. I want to graph x squared plus, whoop, didn't do that right. So x squared plus 1.4x minus 15.51. And I graph that, and yes, it does have x-intercept. So I go to menu, analyze graph. I want the zeros. So I click to the lower bound, the lower side of that x-intercept. The upper side of that x-intercept, it's negative 4.7 comma 0. Analyze graph 0, same thing. I set my sights on the upper x-intercept. I get 3.3 comma 0. So negative 4.7 comma 0 and 3.3 comma 0. Hooray for graphing. Right, so negative 4.7 comma 0 and 3.3 comma 0. Or in other words, x equals negative 4.7 or x equals 3.3. Those are the values of x that if you substitute them into this equation, you will get 0 on the left side. Next up, we have solving by completing the square. I love this. I just love it. So if I want to complete the square on the left side, I'm just going to do x squared plus 6x. And now I need to think about it. Completing the square is about making a perfect square trinomial. And we discovered that the way to do that is take the middle term, divide it by 2, then square it. So 6 divided by 2 is 3, and 3 squared is 9. So I need to think about what can I do to 16 to bring it down to 9. And I need to subtract 7, which means on the outside I also need to add 7. So now I have x squared plus 6x plus 9 plus 7 equals 0. And this is x plus 3 squared when I factor it, this parentheses, plus 7 equals 0. So that is a nice conversion from standard form, this was standard form, to now vertex form, which allows us to solve. When I subtract 7 from both sides, I get x plus 3 squared equals negative 7, and I take the square root of both sides, and I get x plus 3 equals the square root of -7. Now we said if I have the square root of -7, I could write that as the square root of 7 and the square root of -1. The square root of -1 we learned is I. So I need to write this as plus or minus I root 7. So when I subtract 3 from both sides, my final answer is -3 plus or minus I root 7. So if you're trying to be crafty and you're like, I don't want to complete the square, I want to solve by graphing, go ahead, give it a try. X squared plus 6x plus 16. If I graph that, and then I zoom out, oh, it doesn't touch the x-axis, so that means no real solutions. But you guys are in Math 3 now, Honors Math 3, so you have to be able to find the imaginary solutions, as we did here, by either completing the square, or the other option, the quadratic formula. So let's look at this one. If I subtract 4x from both sides, because I always want to have 0 on one side, I have 3x squared minus 4x plus 10 equals 0. Let's try it by graphing. 3x squared minus 4x plus 10. 3x squared minus 4x plus 10. 3x squared, Mr. Gordon, minus 4x plus 10. Oh, doesn't touch the x-axis, so no real solution. So we have to find the imaginary solutions by completing the square or the quadratic formula. Anytime your a is not 1, like here the a is 3, back here the a was 1. Anytime it's not 1, please use the quadratic formula. Don't try to complete the square. It's way too hard. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Yeah, I said by 2a. You can do it today solving the quadratic way. So as I said in class, do the discriminant first. Well, first of all, let's identify a is 3, b is -4, c is 10. So the discriminant, b squared minus 4ac, that's going to be -4 squared minus 4 times 3 times 10. So that's 16 minus 120, which is -104. All right, that's good. Now what we can do is we can take that and substitute into the quadratic formula. So x equals the opposite of b, opposite of -4 is +4, plus or minus the square root of -104 divided by 2a, so 2 times 3. And we're almost done. All we have to do is simplify, do a little bit of math. So let's think about the square root of -104. I could write that as the square root of -1 times the square root of 4, because 104 divided by 4 is divisible, times the square root of 26, because 4 times 26 is 104. So we know the square root of -1 is I, square root of 4 is 2, and this, you could break it down as 13 and 2, but there's no perfect squares in there, so it can't be further simplified. So the moral of the story is that this is equal to 2I root 26. So I can simplify this now as 4 plus or minus 2I root 26 over 6. So now we just need to divide common factors. So I have 4 over 6. Well, 4 over 6, that simplifies to 2/3. Now 2 over 6, 2 over 6 simplifies to 1/3. So my final answer in fully simplified form is going to be 2, coming from this 2, plus or minus 1I, so 1I root 26 over 3. we just simplified those fractions, 4 over 6 and 2 over 6, to be 2 over 3 and 1 over 3. We just don't write the 1 because we have math swag. So there's our final answer right there. Speaking of math swag, if you're watching this video, your extra credit code on the quiz tomorrow is Math Magic. Put that on the quiz, you get some extra credit. Thanks for watching this video and learning some math magic. Except it's not math magic, it's just math. All right, last up. If you want to state the vertex of a quadratic function, you need to convert from standard form, which is what it's in right now, to vertex form, which is what we want it to be in to be able to identify the vertex. So to convert from standard form to vertex form, the way I do that is by completing the square. So let's do it. Middle term is 8 divided by 2 is 4. 4 squared is 16. So I need to convert the 20 coefficient to a 16. I can do that by subtracting 4. But if I subtract 4, I also need to add 4. So that becomes x squared plus 8x plus 16 plus 4, which factors as x plus 4 squared plus 4. Anytime that I have a quadratic now, like this one in vertex form, f of x equals a times x minus h squared plus k, the vertex is always h comma k, the opposite of the coefficient in parentheses and the same as the coefficient outside the parentheses. So our vertex here is negative 4 comma 4. Woohoo! Done. Have a great day.